Hi, so we're going to look at allotropes today. So if we look at these pictures, what do they have in common? Well, these are all allotropes of carbon. They're all covalently bonded, but they are bonded in slightly different ways. Two of them I think you'll recognise, diamond from previous lesson, which has a kind of pyramid looking structure or tetrahedral structure, and graphite, which is the one in layers. And we'll come on to the fullerenes and the buckyball in a future lesson. So want to focus on allotropes of carbon. Carbon's a really interesting element that can bond in different ways to give really different properties. So I'm hoping today that you'll be able to describe the structure and bonding in diamond and graphite and then start linking that to their properties. And then hopefully as a result of that you'll be able to tell me some uses of diamond and graphite based on their properties. So what term do we use to describe these different forms of carbon? Well, I've already said it a couple of times, it's allotropes. Now allotrope doesn't only apply to carbon, it can apply to other elements too. For example, oxygen, which you might know, oxygen is the air that we breathe, but also ozone, which is this higher layer of oxygen we have around our atmosphere. So an allotrope is different forms of an element, okay? So the four pictures you can see are all pure carbon, but they're obviously arranged in very different ways. So we've got diamond there being circled in the what would be a pyramid tetrahedral structure, and we've got graphite. These are your two key ones that you need to know about. So we've got some fill in the blanks to look at here. This would be a good point to pause the video and have a go at these. So question 1, circle the names of the allotropes of carbon in the list below. They are C60, diamond and graphite. Okay, in the blanks. The element carbon is made up of only one type of atom. Carbon atoms are covalently bonded. This means that electrons are shared between the neighbouring atoms. However, carbon atoms may be arranged in different ways, forming allotropes. Allotropes are simple molecules, whilst others have giant structures. C60 is a simple molecule. Its atoms are covalently bonded within the molecule, but there are weak intermolecular forces of attraction between the molecules. This makes it unstable as a solid at higher temperatures. Diamond and graphite have giant structures. They are vast 3D networks of atoms held together by strong covalent bonds. Diamond and graphite consequently have high melting points. Hopefully you did well on that one. So your task this lesson is some information gathering. You can use the information provided in the presentation, or you can do some independent research. Go on the School Frog page or go on websites like BBC Bitesize. So you can choose to make a poster showing the difference between graphite and diamond, or you can complete the questions which will be shown shortly. So let's have a chat about graphite. So we can see this structure here with these layers. These are pure carbon, as I said before, and each carbon in that structure is bonded to 3 other carbons, and it makes these interlocking hexagonal shapes, which we find in these layers. Now, within the layers, those blue bonds you can see are strong covalent bonds. But what we have between those layers, those dashed red lines, are weak intermolecular forces, and the posh name for them is van der Waals. But they are weak forces of attraction between the layers, so hence intermolecular. Now, the cool thing about graphite is, because only 3 of the carbon are bonded, there is a spare electron floating around, and they are called delocalized electrons. If we have delocalized electrons, it means that we have electrons which are free to move around the structure and carry the charge, so they can conduct electricity. You might remember earlier in school, when you're looking at conductors and insulator, you might have done a circuit with a pencil sharpened both ends and connected little crocodile clips to it and made a light bulb light up. So we know that graphite conducts electricity. Now it's used, as we said, in pencils, but it's also used because these layers and these weak force of attraction between the layers and how they can slide over each other really easily. This makes them great for industrial lubricants. So on heavy machinery, we have this graphite lubrication put on, and that will keep the mechanisms moving. Looking at diamond, we've got very different shape here, but we do also have a shape that comprises of strong covalent bonds. In this case, the 4 electrons in the outer shell of carbon are each bonded to another carbon atom. That means there are no free electrons. Every electron that was available to bond has bonded. So if there's no free electrons, they are not able to conduct electricity. They're going to be an insulator. Now this structure is a giant structure. Now we only show a handful of the atoms here, but that pattern will continue and will contain billions of carbon atoms, so it's a giant structure. Now this pyramid shape is what we call tetrahedral, okay? And as we can see, there's lots and lots of strong bonds. Because there are so many strong covalent bonds, it takes a lot of energy to break those bonds and to get them to change state. So the melting boiling point of diamond is absolutely enormous. Because it's got such a high melting point, and because it is so strong because of all these strong covalent bonds, it's used on industrial drill heads. So the drills they use to dig underground at the bottom of seas, to drill for oil or excavate materials, will be diamond coated. Not the diamonds that you possibly picture when we say diamonds that are maybe on a ring, but something which is made of the same structure. Now we have the option, you can make your own poster, or there is a worksheet here with some detailed questions. I'm going to go through the answers on this worksheet, but it will give you some ideas of things to include on a poster if that's the format you prefer to do. So in diamond, it is held together by strong covalent bonds, and it is a giant structure. Each carbon atom is bonded to 4 other carbon atoms, and it has a tetrahedral structure. Diamond is very hard, but it also has a high melting point. And it has this because it's held together by many strong covalent bonds, and these strong covalent bonds require a lot of energy, and there are lots of them to break. Diamond does not conduct electricity because there are no free electrons to carry the charge. That sentence referring to free electrons and carrying the charge is a really popular one with examiners. Looking at graphite, again, same as diamond, it has strong covalent bonds. But in between the layers, it's held together by what you call van der Waals forces or intermolecular forces. Each carbon is bonded to 3 other carbon atoms, and so only 3 of the electrons are up. This means that there are delocalized electrons which can be found between the layers and can move through the structure. Because of that, graphite can conduct electricity because those delocalized electrons can carry a charge or carry the current through the whole structure. I'm repeating this phrase about delocalized electrons carrying the charge through the structure. Those are key phrases examiners are going to be looking for. Graphite is what we describe as soft because the layers are weak and they will easily slide over each other. Now diamond can be used, we said earlier, for cutting tools and drills, and it's also used in more everyday sense of jewellery. For drill parts, it's really hard and can cut for anything. It's the hardest natural substance we have in the world. They don't wear down easily. Problem with using diamonds for these functions is they are expensive and they're relatively rare. Graphite, we said, because the layers in it can be used as an industrial lubricant for machinery, and so that will allow the machinery to be able to slip past each other. We also use it in pencils. It's not lead that we have inside our writing pencils, it's actually graphite. And those the layers of graphite slide off and are left on our pages when we use them. So have a look at these, match up. Look at these properties and the reasons they've gone them. We're now looking at some high level skills here. So diamond is hard because the giant structure is held together by a strong tetrahedral arrangement of covalently bonded atoms. Graphite is soft because it's held together by weak intermolecular forces between the sheets of atom. Now graphene we haven't come across yet this lesson. That is one layer of graphite, so it doesn't have the intermolecular force, just one very thin sheet. So graphene and graphite conduct electricity because they have delocalized electrons. C60 is unstable at high temperatures because they are only weak intermolecular forces between the simple molecules. And graphene is transparent because it's only made of one sheet of atoms. Really, really tiny. Right, so if you want to challenge yourself here, have a look at this question. Explain why graphite is softer than diamond. This is a 4-mark question and would possibly be seen at the higher end of the foundation paper or definitely on a higher paper. It might be a point where you want to pause, you might have a chat with some friends about this. Have a think. Why is graphite softer than diamond? So you should be referring to the layers can slide over or move over each other in graphite because there are only weak forces between the layers. Diamond does not have these layers, so the carbons are unable to move, and each carbon in diamond is very strongly bonded to 4 others. Hopefully you got some of those. So let's have a quick quiz. What kind of bonds are there between atoms in diamond? Ionic, covalent, van der Waals? Of course, covalent. What bonding holds the layers together in graphite? Ionic, covalent or van der Waals forces? Van der Waals hold the layers. Why does graphite conduct electricity? Is it because it's a metal? Because it delocalized electrons? Because the layers can move over each other? Delocalized electrons. Graphite is not metallic. It is made of a carbon, which is a non-metal. What arrangement of the atoms in diamond called? Tetrahedral, ionic lattice or pentrahedral? Tetrahedral. Right, I'm hoping, having watched this video, you are able to recall allotropes of carbon. You will hopefully be able to describe some differences between them, particularly diamond and graphite. You should hopefully be able to describe some of the structure and the bonding, and perhaps you can explain the structure and properties of some allotropes of carbon.